Type of systems. Thermodynamic systems are classified into two categories. First, on the basis of interaction with environment, and second, on the basis of composition. So, we will discuss the B part on the basis of composition. There are two types of system. One is homogeneous system and second one is heterogeneous system. First, we will discuss about homogeneous system. Homogeneous system means a system is said to be homogeneous when it's completely uniform throughout. Means this is, or we can say, a homogeneous system is made of one phase only. Examples of homogeneous system is a pure single solid or pure liquid or gas or true solutions. The second category is heterogeneous system. Heterogeneous system is said to be heterogeneous because it is not uniform throughout. Or we can say that it consists of two or more phases. For example, mixture of ice and water. Here, mixture of ice and water is an heterogeneous system because it contains two different phases. Or next example is two or more immiscible liquids or insoluble solid and a liquid. Or one more example is a liquid and a vapor. Next, we will discuss about thermodynamic properties. The thermodynamic properties are of two types. First is intensive properties and second one is extensive properties. First, we will discuss about the intensive properties. These are the properties do not depend upon the quantity of matter present in the system or size of the system are called intensive properties. So the properties, we can define the intensive properties as the properties which do not depend upon the quantity of the matter which is present in the system or the size of system. Example of intensive properties are like pressure. Pressure never depends upon the quantity of the system, so it is an intensive properties. Temperature, density, specific heat, surface tension, viscosity, melting point, and boiling point, volume per mole. These are the example of the intensive properties. Second one is extensive properties. Ex- Extensive properties are the properties whose magnitude depends upon the quantity of matter present in the system are called extensive properties. The example of extensive properties are mass, volume, weight. Next terms which are used in thermodynamics are state function and path function. Each system have a definite value of mass, temperature, volume, number of moles. At that time, if each system has the definite values of mass, volume, number of moles, that time system is said to be in a definite state. When there is any change in any one of these properties, it is said it is said that the system undergone a change of state. That's why when the change of state occurs, that's why we need two important terms. These are state function and path function. First is state function. It is an fundamental property, fundamental properties of a system which determine the state of a system are referred to as a state function. The change in state properties depends only on initial and final state of a system, and it is independent on the manner in which the change has been brought about. Or we can say that these properties do not depend upon a path followed. So these are the examples of the state variables are pressure, volume, enthalpy, free energy, temperature, internal energy, entropy, number of moles. So these all are state functions. Means all the properties are depends only on initial state and the final state, and all the state functions are do not depend upon the path. Second one is path function. The properties which depends not only on the state of the function but also on the path or route by which the state is reached. The example of path function is work done.